Hey, and welcome to this quick session on AKS Labs at Code to Cloud. So, one of my good colleagues, Diego, global black belt in cloud native technologies, shared this amazing link the other day around a platform engineering module that had been released on the AKS Labs website, which is hosted on GitHub. I'll share a link in the show notes after this, but I thought I'd give one of the modules a go, right, to get started with. So if you head over to the AKS Labs website, and there's a quick introduction on what it is. It's developed by some very, very smart people indeed. But as you can see here on the left-hand side, we've got a platform engineering section. So let's head over to that. So I'm just going to have a look at platform engineering on AKS with GitOps, CAPZ, and ASO. So let's take a look. So I'm just going to quickly just read out the objective of this, what it's about. We're going to go through deploying, hopefully, an AKS cluster from the terminal, maybe some Argo, and see what happens from there. So it says here, welcome to the Platform Engineering on AKS workshop. This is a hands-on workshop, which is always great, right, for learning. And it will guide you through implementing a robust platform engineering environment using the cloud-native pattern on Azure Kubernetes Service. The environment leverages GitOps practices and integrates tools such as ArgoCD. It's good to hear. The Cluster API Provider for Azure, so CAPZ, and alongside with the Azure Service Operators. By the end of this workshop, participants will be able to deploy infrastructure and application environments using these tools. So let's just have a look at the objectives. So the objectives are, we're going to provide a foundational understanding of key tools in the platform engineering space, build a control plane AKS cluster using the Azure CLI, bootstrap GitOps with ArgoCD, and demonstrate how CAPZ and ASO can provision infrastructure in Kubernetes clusters. I'm also going to show how to deploy a new resource in Azure using the CAPI and CAPZ to generate a new AKS cluster. So it says here, there's a top tip. If you've used infrastructure as a code tools like Terraform to create resources in Azure, you can use the ASO CTL tool to convert the Azure resources into ASO deployments. To find out more about ASO CTL, take a look here. You can download ASO CTL here. Well, that's a new one to me. Let's just quickly go and take a look at this. So this is a new one. So let's just zoom that in. So the ASO CTL is a command line Swiss Army knife that provides a number of useful commands for working with ASO, so Azure Service Operators. It can be used to clean your cluster of obsolete custom resources prior to an upgrade. That's a good best practice to have. And convert an existing Azure resource into a custom resource nearly ready for deployment. And it also has a generator. So we have a sophisticated code generator that helps us support new resources. So a new version of existing resources. It consumes the Azure Open API Swagger specifications and writes most of the required code. So it's like got some Copilot vibes going on there, right? So let's just head back to the lab. We'll check out that tool on another episode. Let's take a look at the prerequisites. So obviously you need an Azure subscription. So Visual Studio subscription, or if you're lucky enough, a dev test subscription or an Azure subscription inside your Azure tenant. You need the Azure CLI deployed. You need kubectl or kubectl if you're on kubecloud, Helm, and the GitHub CLI as well, right? So let's take a look at the architecture overview. So this workshop uses the GitOps bridge pattern to build a platform engineering environment on Azure Kubernetes Service, so AKS. So what are we going to be deploying? So we're going to be deploying a control plane cluster. Is provisioned and bootstrapped with ArgoCD. That's pretty cool, straight out of the box. We're going to use ArgoCD to sync the platform add-ons via GitOps. And we're going to have a cluster API provider for the Azure CAPZ is used for managing additional clusters. So there's a note here, CAPZ or crossplane. So crossplane obviously gets a lot of love out in the industry, but before deploying the solution, take time to evaluate which control plane best fits your organization needs. So in this workshop, they're going to focus on CAPZ and Azure Service Operators, but crossplane is another viable option. So there's a nod there to crossplane as well. And to help you decide, there's a link to choose the best control plane provider for you as well, right? Which you can find here. So before we begin, we need to create a directory that we're going to be working off outside, inside of our terminal. So let's just bring up the terminal. Hopefully you can see that. I'm just double checking. So let's take a look. So we're going to do make the AKS Labs. Then we're going to cd AKS Labs. And if you're wondering which terminal I'm using Warp, by the way. And it doesn't require a login anymore for you to use it. Got quite a lot of love for Warp. Quite a big fan. So we're in the working directory now, and then we've got to declare some environment variables by the looks of things. So we're going to cat these into the environment RC. Simple things like the Azure subscription. So I'm already logged in using the Azure CLI, the tenant ID, so it should be able to pull that out straight out of the CLI command. And then we've got stuff like the name of the cluster, the resource group, and the location, right? And then we're going to use a managed identity as well. So I'm just going to copy this, bring it back to what? Hopefully this is going to work. Perfect. So our environment variables are saying, so we're going to load. So look at that. It's like it's already trying to think into the future here. So following the instructions. So we've located our source environment RC file there, so we know what we're exactly pulling out. So we're going to create a resource group. So as we've set the variables, I'm just going to copy this in, hit enter. Should start creating a resource group name in Azure. So as we can see here, right, it's been out. Let me try and make this a little bit bigger for folks. We can see here it's been deployed, successfully succeeded. So we've completed step 1, a resource group. It's always the litmus test, right? So the next step is to create the AKS cluster. This is going to be a few more moving parts. I'm just going to copy a couple of lines. Essentially, what we've got here is the name of the AKS cluster, which we're going to get out of the environment variables. We've got the resource group. We're going to enable managed identity, and we're going to have a node count of 3. We're going to hopefully generate some SSH keys as well for us to be able to kubectl into it at a later date, or maybe use other resources off the back of that. And enable the workload identity. I've just copied that. So let's go back, paste that in, hit enter. This may take a little while. So what have we got here? We got a message. So the default value for the node size VM will be changed to dynamically selected by Azure. And here, see that my code has stopped. Why has this happened? So let's just take a quick look. So it says Windows, so it's break and change scheduled. Let me just see why this is not working. So let's hit enter. Hopefully this works. If in doubt, rerun the command. No, it doesn't like that, does it? Let's try and choose another SKU here. Let's try this. So we selected another virtual machine class to run the AKS cluster. Successfully, it's picked it up there. So Warp was able to pick that out of the output of the terminal and give me the correct answer for it, which was great. So that's deploying. So we're just going to wait a few moments for this to deploy. And then once it's deployed, we'll get back onto the next step 3. So after about 5 or 10 minutes or so, we can see here that our AKS cluster has successfully been deployed. We can see this from the output here. So some basic configuration details, the region it's been deployed in, the name of the cluster itself, the load balancing profile, the CEDAR range for the pods, etc. So let's head over to step 3. So we're going to get the credentials to the cluster. So I'm just going to copy this. So this is going to pull the credentials out so we can effectively use kubectl to interact with the cluster. So we just put that in. So we've got the config file there. So we're going to have to now use the AKS-labs config file as our kubeconfig. If you don't know what the kubeconfig is, basically it's a set of instructions that tells your CLI or your terminal or the kubectl command line tool to interact with the particular cluster that you're working on. So I'm just going to copy this here. I think it's going to explode. Awesome. So yeah, if we do kubectl get nodes, hopefully this should pull out some of the nodes that are up and running inside of our AKS cluster inside of Azure. We can see there they're up and running. So this successfully tells us that we're interacting with the cluster correctly and the cluster is up and running. So let's go to step 2. So we're going to create a user assigned managed identity, obviously using Entra ID for the CAPZ. So in this step, we will do the following. We'll create a user assigned managed identity for CAPZ. We'll assign it the contributor role. We'll create 2 federated identity credentials. So AKS Labs, CAPZ manager credential, and the service operator. So let's get this copied in. And kudos to the team for writing all the code and making this simple to follow. So let's just get this pasted in. So that's going to create now. Perfect. That was nice and quick. So we need to retrieve the Azure Managed Identity Client and Principal IDs as well. Pull them through. Step 2. Awesome. So now we need to verify these variables are empty, right? And they're inside of our environment. So I'm just going to bring these out. We can see here the subscription ID, the tenant ID, is your client ID for the identity as well, and the principal ID. That's awesome. So now we're going to add these environment variables to our environment RC file. So I'm just going to copy these. Perfect. And now we're going to assign step 3. We're going to assign the contributor and managed identity operator roles to the identity. So 2 jobs for the price of 1. Paste that in. Let that run through. So we're going to create the role assignment. And then we're going to assign it. Invalid scope. Please use the help file to validate the format. It didn't like that. So let's just try that again. And that went through that time. Sometimes it just pays for it to go through the second time. So step 4, creating the maybe it was waiting for the first item to be created before it could make the assignment. Maybe it was tripping over its own shoelaces. So creating a federated identity credential for the AKS Labs CAPZ managed credential. So step 4. So let's get that created. Perfect. See that succeeded. Step 5 is creating a federated identity credential called the service operator. So we're going to copy that code, stick that into our terminal as well. Awesome. So step 3. So now we've got our identity and our basic infrastructure stood up. We need to install ArgoCD. So we're going to create a namespace for ArgoCD and install it on the cluster. So you can see here, there's 2 commands, kubectl create namespace ArgoCD, and then there's kubectl apply namespace ArgoCD / I think that's force, and then obviously pulling that from the GitHub repo to get it installed. So there's an install YAML file there. So let's just grab that, let's paste that in. It's going to pull that down and deploy it for us. So you can see here that the namespace has been created inside of our cluster. And now it should be applying the YAML file. So some custom resource definitions, some service accounts, some RBAC authorization, some role bindings going on, and there's a config map as well. And we can see here that's also applied some network policy settings as well out the box to get it up and running. So if we go back and we can verify this. So we do kubectl get pods. So the pods are running inside the nodes, inside the namespace, which is ArgoCD, and then minus -w, which is wide. So let's pull that up. And we can see here that they're running or they're about to run, which is amazing. You could also, if you've got K9s deployed as well, you'll be able to view what's running inside your cluster as well, because that utilizes the kubeconfig file. So let's just get out of this. Okay. So as we can see here, yeah, like this should be running. As soon as that's 1 out of 1, then we know our services and our pods are up and running. So now we're going to try and access the ArgoCD UI. So we need to retrieve the ArgoCD admin password, which has been set. So we're just going to grab this command here, go back to our terminal, paste that in. We can see here that it's exported the password file, the password here. So obviously I'm not going to be keeping this. I'm just going to copy this. And then I'm going to bring up a text editor just to save it. New document. Keep that in there for later. Right. So it says here, just making sure I've got this scrolled across properly. If no public IP is available, then we can obviously create a service ArgoCD for. So let's just create that. Let's put that in, paste that in. So it's forwarding the traffic so we're able to access it. So if I need to get the public IP address of this cluster. So if I do that, I should be able to access the ArgoCD, right? Portal. So if I go to, let me just bring up another tab. If I do portal.azure.com login, so subscriptions, let's get the pip for this. So if we go to resource groups, see here we've got our AKS Labs. I don't know if people can see that. It's a bit small. Let me zoom in. Here we go. We got here our cluster's been deployed, right? So if I take a look at that, and then I should be able to get the public IP if it has one, which it should. Looks like there isn't one there. DNS service IP. These look like local addresses. So let's go back to the documentation. So it says here we can access it. Let me see if it's forwarded it. If it has, this will be amazing. Oh, let's visit the website. I can see something going on here. Should have just followed the instructions. There was me trying to be more clever than I needed to be. So it looks like it's forwarded the private IP address and the service address for me to access it. So I can access my ArgoCD UI. So if I go back to it, so it's admin, right? So if we go back here, admin, and then let's grab that password out of the text file, sign in, and look at that, voila. Let's just zoom in a bit as well. Awesome. Let's get back to those instructions. So log in. After you successfully log in, you should see the ArgoCD applications, which at this point is empty. Yeah, because we haven't got anything deployed, right? So what are we going to do? We're going to deploy something. So we're going to install the cluster API provider for Azure, so CAPZ. So step 5. So this section walks you through installing the cluster API provider for Azure through the cluster API operator, the CAPI operator. These steps is needed in order to prepare your environment for provisioning AKS clusters using GitOps workflows. So prerequisites, we need a cert manager. So a cert manager is required for CAPI, CAPZ, and the Azure Service Operator, and it plays a critical role in automating the life cycle of TLS certificates required for communication between controllers. So validating and mutating webhooks and the Kubernetes API server. Without a cert manager, a Kubernetes operator would have to manually create, distribute, and rotate these certificates, making it very complex for a day 2 operation. Now, anything that automates certificates, right, takes the pain away. So I really appreciate this being put in here. So we're going to install a cert manager. So it looks like we're going to start using Helm, right? So we're going to go back to our CLI. Just going to copy this into our cluster. So the Helm repo, so we're going to add the jet stack. It's going to pull that chart through from jetstack.io. Then we're going to update the repo, and then we're going to install the cert manager, right? So let's go back to the terminal. This is where things might start getting. So let's paste that in. Oh, it didn't like that. Right. No, I keep doing that. So let's copy that in, because like I was pasting in the output. I didn't like that, so I need to install Helm, which I thought I did beforehand. So let's have a look at this. Let's install Helm CLI. This is where Warp comes in. It's asking me if it's okay. So brew install Helm. Now I swear I installed all these prerequisites before, but yeah, let's go for it. So it's installing Helm, right, using the homebrew package inside of my Warp terminal. You know, back in the day, you'd have to go back onto a web browser, search for something, but now AI, right, and all these agentic services are just speeding up this deployment process. So let's try that again. It's looking more successful. Happy helming. Absolutely love that. So it says update complete. So it's just grabbing the latest from the chart repositories, and look at that. So its status is deployed, which is always great to see. The date and time where it's deployed, and the cert manager has been successfully deployed, right? So in order for you to begin issuing certificates, you will need to set up a cluster issuer or issuer resource, right? By creating a Let's Encrypt. Anyone that doesn't know what Let's Encrypt is, like, they have been doing the good work for now, I've got to say, going on 7 years or so. You know, they brought security to the masses, and it's not even behind a paywall either. So kudos to those guys. So let's just go over, right? So now we're going back to kubectl. We're going to see if the cert manager has been deployed. So yeah, we can see it's up and running here, right? Our cert manager nodes are up and running, and the age of them, etc. So we're able to verify that. And we can see that in the instructions as well. So now we're going to install the CAPI operator. So we're going to generate the values for the CAPI operator. So this is going to be a YAML file by the looks of things. So it looks like the squad has already populated this for us. So we're just going to bring that back, paste that in, hit enter, which is awesome. And now we're going to install it, right? The API operator. So I'm just going to grab this code here, step 2, paste that in. So we're adding a repo. We're using the Helm charts again. It's pulling it down. Awesome. So successfully deployed. We've got the CAPI operator in deployed as well. So it says here there's some info. If you need to modify or reinstall the cluster API operator, you can do it by running this command. So it's upgrade, update the chart, e.g. after modifying the CAPI operator values YAML file that we created before, then we can run this command here. But I think for the for this quick demo /lab, we're able to skip this chart. But this is good to know if you happen to update that original YAML file again. So verify the CAPZ installation. So let's just grab that. No resources were found. So it says here that it hasn't deployed. So the CAPZ installation. So we just looked at kubectl get pods namespace Azure infrastructure, and there's nothing in there, and it's telling us that we should have something in there. So let's just go back and rerun that. Maybe it's still creating. It isn't. So maybe, that says there. Let's scroll back up. Let's check out the namespace here. Let's check out YAML. No. All the cluster API operator. We did that. Doesn't seem to be a namespace there. So just double checking this info. That was to do with the CAPI operator that we had installed there from the chart. But yeah, verify the CAPZ. That took a little time. So it looks like it's spun up. It's just, well, it is running. So let's just keep. So we just need that to go 1 out of 1 on the first one. So the Azure Surface operator. So it looked like it was applying. It's just being impatient. It's always good to double check your instructions though. So maybe wait a few minutes for that to come up. Still says 0 out of 1. We just need to make sure that's up and running. So it's actually been restarted. Let's proceed and see how far we get. So generating a CAPZ Azure cluster identity is the next one. So we're just going to copy this and then we're going to paste that in. It's going to create a YAML file, and it's like it's already predicting it, right? So kubectl apply -f, which is force identity.yaml. Let's go. So that's been successfully applied. So at this stage, the management cluster is fully prepared to provision new Azure resources. You can use CAPI, CAPI, or CAPZ to create the AKS clusters or leverage Azure Service operators to manage other Azure resources. So this is where we're going to set up our dev environment next. So with the management cluster operational, we'll act as a dev lead. Just got promoted on the fly. Amazing. And create a new AKS cluster using a self-service approach. By defining the cluster as an ArgoCD application and storing it in the GitHub repository, ArgoCD will automatically provision resources in Azure whenever the new files are committed. So as soon as we do like a push or a pull request, right, into our repo, into Git, that is then checked and reconciled against our desired state, and then we'll push changes into our Azure environment. So take a look, right? So step 1, nice diagram here. We push the ArgoCD application into the repo. So that'll be on GitHub. And step 2 is we'll pull it into our management cluster and it'll be deployed inside of our AKS cluster. So we need to create a new repository. Now, I also deployed and installed the GitHub command line as well. So the GitHub CLI. So let's make sure this is working as well. So I'm probably going to have to log in here. So GitHub repo create app project environment public. It's probably going to be like, oh, I don't know what it is. So let's let's log in here, right? Because I didn't log into GitHub beforehand. So I use github.com. Let's use HTTPS. Do you want to authenticate with your GitHub credentials? Yeah, let's go. So let's log in with a web browser. Let's try and speed this up. So if we go to github.com/login device. So let's bring that up. Yeah, that's me, Kevin Evans. So now it wants that code. So what was it? Of course, you're going to be difficult. I think I need glasses. Click continue. It's asking me if I need permission. I'm just going to click on authorize GitHub. Then I'm going to have to do two-factor. I'll bring up my cell phone. Click approve. And here we go. Should start seeing something here in the CLI. See if our credentials are passed through back to the terminal. Press enter to open HTTPS GitHub login device. With the Azure CLI, this is a bit quick. Oh, looks like I was being impatient again. So we can get rid of that. We can get rid of that. The command completed successfully. So we've logged into GitHub and we've created a repo and it's public and we're communicating over HTTPS, right, for ease. So let's go back to instructions. So yes, before you can use the GitHub CLI, GH, you may have to log in using the GH auth login, which we've just learned to do. And here's another top tip from Code to Cloud. Try and be patient. So we will be using the SSH authentication for this workshop. Oh, if you haven't already used SSH to GitHub, here's how you do it. Amazing. So we did HTTPS, so we're probably going to have to do this authentication all over again. So let's just try and paste this in and see what happens. It does not like that at all. So we're trying to open users net, where my user SSH ID, pub, no such file or directory. So let's generate an SSH key. Let's run that. Great. I'll delete that obviously after this video. Okay. So let's paste that in. Let's try that again. Yes. Press enter. Looks like we're re-authenticating. So pull that in. So it looks like we're doing everything over SSH. Yep. Give that access. Okay. And we're in. Awesome. Okay, so just close this off, clear it up. So we've generated an SSH ID and a key. So we can list our keys here. First, copy your one-time code. Yeah, we did that. Let's just try that again. Public key added to your account. Let's list it. And we can see here, right, my personal laptop key. So we've generated the SSH ID key here as well, as we can see here, right, my personal laptop key. If you need a new key, it's SSH key gem, which we did before. So now we need to choose the local repository. So we're just going to export this. So we're going to clone it. So clone the repo. Yes, we're going to say yes to that. No such. So there's no such file or folder. So there's no. Right. Okay. So let's do. So we've cloned it, but it's a CD app project environment, which we don't have. So if we do this. Oh. So we need MK. Let me just try this. So if we do, because it's trying to change into a directory that doesn't exist. So we do make directory app project environment, and then CD. We'll CD into that. So let's just copy that clone again. See if that works. Okay. Fail. Could not read from the remote repository. Please make sure you have the correct access rights and access the repository exists. So git clone, get a GitHub username, add project environment git. So let's just go over to GitHub. Let's take a look at our repos. Let me just, what would it have been? So if we were creating the repo, what would it have been? Let's go back to the instructions because maybe it didn't do it before. Create a new repository. Right, let's try that again. Okay, maybe that's why. And then let's do the git clone again. Maybe it's going to work better because guess what? We actually created the repo because we have the right credentials this time. So clone into you appear to have a cloned empty repository, right? Okay. So now we're gonna create our samples. So let's do a list. So we're into we've got samples deployed. So now we're going to create a new ArgoCD application in the management cluster that watches the GitHub repository for any changes. Okay, so let's copy this. This looks like a YAML file. Let's get this pasted in. Enter. So we've created a YAML file. And let's get this deployed. So kubectl apply -f GitHub app project ArgoCD app.yaml. Okay, so that looks like it's applying. So if we go to the ArgoCD web UI, you should now be able to see out the application. So let's check that out. Unable to lay data. So I got a feeling that's because, yeah. So when I cancel the service out of the terminal, it stops it from being presented locally. So we're going to have to do this a few times unless I bring up a separate terminal session. So if we go back up, we have a look here. Let's see if it carries the credentials across. That would be amazing. No, can't see it. Let me try doing it in here again. Yeah. So if I go back to here, we'll be contacting our ArgoCD instance inside the AKS cluster. Looks like it's just loading. We're in. So as you can see here, if we look under applications under our ArgoCD, we've got our project environment recursive, right, which we saw in the instructions there. So let's scroll back down. I feel like we're going to be. I'm going to copy that command because I feel like we're going to be needing it a couple of times to give us that service. So let's just copy that into our notes here. So port forward service, and let's copy the link as well because we're going to be in and out of that. Okay, so scroll back down. Where were we? We were right. We just applied this YAML, and now we can see our app, right? So with this new repo in place, an ArgoCD in the management cluster watching for any changes, you are now ready to proceed and try sample 1 and 2. So sample 1, create a new AKS cluster as an ArgoCD application. So the first sample demonstrates how to declaratively provision a new Azure Kubernetes Service cluster using ArgoCD, Helm, integrating directly with Azure via the Cluster API for Azure. So by treating the AKS cluster itself as an ArgoCD application, well, this is pretty amazing. We enable the full GitOps-based lifecycle management for both infrastructure and applications. This approach simplifies the cluster creation, standardized configurations, and ensures changes are continuously reconciled from a Git repository. So this method allows the platform team to bootstrap new environments on demand using ArgoCD synchronization and automation capabilities to handle deployment, scaling, and governance seamlessly. So here's the diagram. Our dev lead pushes some code to the ArgoCD application repo. He then pulls step 2 as we pull it into Argo from our cluster. We reconcile, and then 3, we create a resource and configure a new dev cluster. Now, this is pretty cool. I've never done this before, so let's just check this out. So step 1, the environment variables for the new AKS cluster. So let's grab that. So some really original naming here. We've got dev cluster, and it's going to be in East US. So let's just get this punched in. As I said, we're going to probably be coming. Absolutely loves me, that does, right? So let's just copy this again. For some reason, it feels like it needs to paste my outputs constantly. So we've set the environment variables. So create an ArgoCD application that declares the cluster. So note that if this ArgoCD application manifest references a Helm chart, the Cluster API provider, the Azure Managed Cluster Helm chart that manages the underlying Azure resources required to provision and configure the AKS cluster, this chart allows for the configuration of various AKS parameters such as the Kubernetes version, the cluster network, and the node pool options such as VM size and OS SKU, right? So just gonna have a quick drink. I've been talking a lot today. So let's grab this YAML file. So what are we gonna be deploying? It's gonna be in the ArgoCD cluster. It's gonna be spinning up our dev cluster name here, right? So let's check this out. So copy that, put that into our terminal. Hit enter. Scroll down. So it looks, yeah, it's got the cluster information in here by the looks of things. So, and now we're going to commit and push the changes back to GitHub. So we're going to git add the directory, git commit sample1, create a new AKS cluster as an ArgoCD application, and then push the origin. So I just want to make sure, create the ArgoCD that declares the cluster. I just wanted to make sure I was in the correct working directory, but it doesn't say anything different there. So let's get this pasted in. Let's hit enter, pushing it. Okay, so that should trigger a branch activation, and Argo should be able to pull this up. So we go back to our Argo CD, service port that again, let that run, and then let's see if that's something's happening. So you can follow the deployment of the new dev cluster in the Argo CD UI. So let's go back to there. Let's click on sync apps. Prune, dry run, apply all. Let's just click sync. No app selected. So let's keep refreshing. Just want to make sure that we're in the correct. So it says here that it should be here. So commit and push the changes back to GitHub. I think that's what we did. Let's take a look. It's this here on the. Oh, dev cluster. See, patience. Something I lack, especially when I'm used to stuff being lightning fast. So we can see here, right? Like it's in sync, but it says degraded. Now that's probably because it's spinning it up, right? And it was only a few seconds ago. So if we refresh, right, if we go back to instructions, I just wanted to make sure I was in the correct working directory. So that's actually spinning up an AKS cluster, which I think is wild, right? And we're using it via GitOps. So sample 2 is create a new Azure Service Operator v2 resource. So in the second sample, we will look into how the Azure Service Operator creates a resources in Azure. For example, we'll create a resource group and a key vault instance, right? And this is via Argo, right? So I can't wait to see this, because normally we provision something with Terraform or through the portal or maybe some bicep, right? So there's some application. So to create other resources, we need to you can follow the structure of the Git repo for this example. So we should have a folder called sample2. The key vault Argo application YAML contains the ASO version 2 resource group and key vault manifest. So from now on, when creating resources with ASO v2, we need to include the following annotation. So the annotation is serviceoperator.azure.com/credential from ASO credentials. So to illustrate this concept, let's create a new resource group and key vault instance. Okay, so let's go back to our terminal. Let's paste this in, create namespace, rgdev -app. So that was created. So we need to create a new secret scope for the namespace. So copy this. It's a YAML file. Everything in Kubernetes is a YAML file. So we've created that inside of our cluster, and then we need to apply it. So to hit that, okay. So now we need to create the service operator manifest file, paste that in, keep that created. God, I love Linux. And then we're going to push this back to GitHub. Git add samples, the application file, right, back to, so it's going to pull that through and push it back to Git and then push it back to our Argo. So it looks like that's done. So that should be replicating through our repo and back to the Argo. So we should now be able to see that on our Argo CD UI. So let's get that back in. Let's bring this up. Let's refresh this. Do we have a third app? Not yet. Maybe it's still syncing. We don't have any unknowns yet. This took a little while last time. So it's saying here we should see the new resources in the Argo CD UI. So we go back, applications, sync it now. It says it's out of sync. So it looks like it's pulled that through. You can see here that it's got the key vault, azure.com vault, rgdev app key vault. Refresh that. Let's head over to our Azure portal. Let's go to the resource groups. Like that, look at that. So it's created the resource group and it's deployed the key vault as desired, as in our desired state. Well, I never knew you could do that. So I think that's fantastic that we've been able to do that. So That's being deployed at the moment as part of our manifest file. And I mean, yeah, they're saying here, I mean, we checked it in the portal, but you can also bring it up in the terminal as well. So I thought that module was absolutely amazing. I really enjoyed it. Remember to authenticate properly with GitHub. Make sure that your prerequisites installed. And make sure you don't skip any steps and read things. So that was my first attempt at doing it, and I had a lot of fun doing it. There's some more stuff to look at there, but in summary, so in this lab, we accomplished the following. We created an AKS control plane cluster using the Azure CLI. We installed ArgoCD and accessed it through the web UI. And then we bootstrapped the environment using GitOps principles. So we used GitHub, right, and repository reconciliation. And we installed Cluster API Provider for the Azure CAPZ and the Azure Service Operator to enable infrastructure provisioning. And then we provisioned Azure resources using the Azure Service Operator. So like we basically deployed something outside of Azure via our AKS cluster, which I've never done before. I think that's absolutely amazing. So thanks again for watching this improv video. I hope it brings a lot of value. Don't forget to go and check out the AKS Labs website. As you can see here, there's a couple more modules on platform engineering, and there's an AI one here, right? Which I can't wait to get my hands in, get my hands dirty with this one, right? So deploying AI workloads on AKS, right? Which I can't wait to see. But yeah, thanks for watching. If you like the video, don't forget to like, subscribe, and please tell your friends. So goodbye for now.